Okay, perfect. Yeah, so just this just kind of directly extends all the wonderful work Ellen was sharing there, and hopefully some of this will be useful in different ways for you. Focusing on a blend of activities and assignments. So the goal of kind of a high level goal Ellen mentioned of these two sessions Ellen and I wanted to share today were kind of show a few detailed example activities that are really adaptable to technical or more conceptual courses. Maybe they'll be directly useful to you, but also maybe just more informative for you to develop your own better, more unique approaches to the ways you do it. And I know a lot of people on this call. I saw Daniel, Dick, and plenty of a few folks that I know who do a lot of creative things as well. So, the two. So I'm going to focus on two today that I hope you'll find interesting. The first example activity you might see it under like a broader frame of how do we translate philosophical problems or ethical dilemmas into computing contexts in meaningful ways. And the example I'll share will focus on autonomous vehicle simulation software and design. There's quite a few different activities and software out there that do this. I think this is like a really good one, perhaps the best one that I learned about through someone else and that I've seen. So, and I'll talk a little bit about what it is and how you might structure an activity around it. And then the second kind of detailed example activity, set of activities, will focus on how you might consider using personal data collection, how your students might collect personal data and visualize that data to facilitate discussion about technology ethics and ethical design. And so the framework I'll actually share is something originally developed for social studies teachers, but has been adapted to computing contexts called mapping self in society. So yeah, let me just hop into the first example. I'm pretty much going to use kind of some interactive videos, and these are all on the web. I or Ellen or Jason will put these links into the slides at the end if they're not already in there at some point. So first one focuses on the classic trolley car problem. I think a few things to say. This is like the most perhaps famous ethical dilemma problem that is often translated into computing context, but it's done quite often, I think, very poorly, and quite often many people think it's irrelevant, this idea of the trolley car problem. So one thing about this activity is to show a little bit how you might engage your students in meaningful technical ways to see the relevance of the trolley car problem and expand thinking and understanding around it. I won't talk about the trolley car problem. I'm assuming many people may be familiar with it. If not, if you've never seen Michael Sandel's version of it, this is Sandel's last name here, I'd strongly encourage you just go on YouTube and watch it, or show it to your students if that's of use to you. It's really good, and it's probably the best one out there, I think. So I'm going to hop onto a website. And let me see here. So this is a site, it's titled Ethical Autonomous Vehicles. Again, we'll put the link in the chat at some point here. It was designed by someone named Michael Cherubini. It consists of software that your students can download for all platforms that allows you to simulate different types of algorithms and different scenarios for autonomous vehicles. And it's a really well-designed software. It was built in Unity, so it's highly engaging to students. It's built in a platform that many Georgia Tech or any CS students use. There's a lot on this site, all sorts of images. I'll talk a little bit about these diagrams at the bottom. What I really want to do is just run through a couple minutes of this introductory video, because I think it will give you a feel for what this activity might look like in your classroom or outside of your classroom as an assignment. So I'm just going to play and talk over 2 minutes of this video, which is showing you what the software that your students can download looks like. This is like what your students will experience. So again, it's built around scenarios and different algorithms. This is going to show a school bus scenario with what's called the humanist algorithm. And this description, maybe back up for a second there. This description gives you a little idea of how the algorithm runs. So again, we have a car. We have a school bus scenario. You can watch the autonomous vehicle, autonomous vehicle, doing all sorts of profiles analysis, detection, questions you can raise, your students, this activity can raise with your students. What data is the car using? How is it getting that data? How is it processing that data? And how is it creating paths, doing predictive risk analysis? So this video and the simulation are very detailed and raise all sorts of interesting questions, ethical questions about how a car decides which path to take and how those decisions are made and what are the ethics behind those decisions. Very relevant to the trolley car problem. So in this case, we see the car hits the bus directly. Using a different algorithm, different things might have happened, right? At the end of every one of these in the software, you get a crash report. And in this case, I'll just pause it for a second. Again, the vehicle is using the humanist algorithm. The crash conclusion is a frontal collision with the bus is the fairest output because the two others could lead to death cases, something that the humanitarian algorithm tries to avoid at all costs, right? So again, after using this software, you can have your students write their own kind of crash conclusions and reports, which is a really nice way to augment the activity. So I'll show one more scenario. I'll pause it and take a little longer to read this one. Same scenario, school bus scenario, but now with the protectionist ethics algorithm. And this gives a little description of how that algorithm is designed. Safe from a user perspective, but unsafe for everyone else because it dismisses everything and everyone to preserve the user, the driver's safety. So same scenario, and you can you'll see in a second, a little bit differently of how this algorithm operates. Playing in a second. Great. Okay. So I think, if you imagine, I'll continue to talk over this. If you're running this in class or online or as homework, your students together or alone can be simulating these different scenarios and using different types of algorithms and carefully considering a lot of different things. I think that's the power of this software in a very efficient way that if you bring it back to class, you can discuss about it. So, I usually tell my students when I show this introductory video to try to guess, of course, what the car is going to do right now, in contrast to the humanist algorithm. And pretty provocative, but in this case, of course, the school bus, which is full of children, is rolling off the bridge. And the car is safe, right? And the crash conclusion is pretty provocative. No matter how many children are in the school bus, the autonomous vehicle has to keep its owner safe, right? So really different type of algorithm operating, of course. Provocative example. The designers of this software actually built in all sorts of other examples. Donald Trump makes an appearance in a way that's, you can keep politics out of it, but it's an engaging kind of addition. So let me go back to the website and say a couple other things, and then I'll summarize, this activity and example. Again, you can download that software there over here in the download sections. There's also these really great block diagrams. So I'll just pull one up. This is describing how this is the profit-based algorithm, and this block diagram in text gives you an idea of how it actually works, what data it's using. So all that to say, these things can be highly technical. But very conceptual, and it's all based around kind of the idea of the trolley car problem in a way that I would argue is and many other teachers who introduced me to this would argue is quite engaging for students and valuable for us as CS teachers and certainly for our students. So to kind of conclude that activity, I just thought I'd share this prompt a little bit. I mean, this is the most, say you have them download the software, take 10 minutes to run the different simulations and think about the algorithms, you can actually, this would be the most simplest way you could use this in a technical or a course specific focused on ethics. Invent a different algorithm to operate an autonomous vehicle, consider how your algorithm works and what data it uses, and finally draw a represented diagram to show how your algorithm operates in a particular scenario. The last thing I'll say here is even this simple prompt, one thing it helps CS students really struggle with this. And one of the most basic things is this is such a simplistic way to look at how you might design autonomous vehicles that few students even consider how different algorithms might interact and operate with one another. So it opens up all sorts of doors for folks who are more, if you're an instructor who teaches machine learning or all sorts of other types of work, there's a lot of ways you can bring your expertise to teach in this space using this very simple activity design, I would argue. So I hope that's helpful. Hope that's engaging. Always tough to talk on the blue jeans here. But I'm going to shift now to a second very different example. And this comes from some work that I've been doing actually with a lot of folks in social studies was the original context of it, to actually teach bring more critical perspectives and data science like curricula in the social studies context, but it's morphed into kind of a broader framework. One of the big application areas is to embed ethics into technical CS courses, particularly through the use of personal data. So some starting points at the bottom here for this work. In education and learning and sciences and other types of education-related fields, there's a big push to leverage like data about people to make learning and teaching more engaging, just to put it simply. And kind of a second starting point is while data has become central to technologies and services that CS students will make throughout their careers in the next 20, 30 years, few CS students have really ever examined their own data to consider how these technologies and services should be designed. So, I think for me and others, when you stop and think about that, it's like, wow, all the CS students are building all these applications that leverage other people's personal data, as we all know, but they've rarely had experiences. What does collecting that data feel like? How would they want those technologies built for themselves, right? So this framework titled Mapping Self in Society is trying to get at that and trying to give CS students those types of experiences. So what I'm going to do is briefly walk through the website, and I'll put this link in the chat after, and Ellen may have already. So this is what the site looks like. It's got an overview page and a set of activities. So what I will do is I will hop to the overview page. It has 5 activities. You can just do one, or you can do all of them. If you did all of them, it would take about 2 class periods. If you did one, you could do it in a single class period, or, this is designed to be really flexible and just assign as kind of an ending assignment. But let me walk through these 5 activities to give you a feel about what students do. In the first activity, students use an application to actually collect their own physical movement data, or their daily round, like their movement over a day or a week or a couple hours, whatever they feel comfortable with, whatever you want to assign as a teacher. Typically on the site, we recommend, at least a day to get some type of data, and of course, only things students feel really comfortable with. Quite often, students get really into the idea of collecting their own data, and often, I've had students collect a week, 2 weeks, even a month's worth of data through this activity and assignment. The second activity is they actually take a close look at what that physical movement data actually looks like in kind of a CSV file, more of a human readable format. And it is quite shocking that most students have never even just seen kind of a CSV file organized by time and latitude and longitude points of their own physical movement data. And this is a type of data that's collected on them left and right by all sorts of companies, as many of us and students kind of seem to know, but have never really looked closely at it. In activity 3, they actually create different types of what are called base maps of their local environments. So if you're doing this in the context of Atlanta, you would create different base maps of things relevant to Atlanta. In this case, this is a racial dot map where color demarcates different races as organized by the 2010 census. So that's kind of for those who know what, sorry, that's not Atlanta, that's Nashville right there. Apologies. So that's activity 3, creating a bunch of different base maps. Activity 4, they visualize themselves through their own physical movement data over lots of these different base maps and other types of maps in 2D and 3D representational forms. So in other words, we use lots of different kind of visualization tools to give them what are hopefully engaging ways to look at their own physical movement data, and if they'd like, in relation to other students' data that they're in class with, right? And finally, they kind of have an opportunity to reflect on their experiences across these activities or a single activity. So just to give you a little detail, each activity is organized, has a brief explanation, some guiding questions, a lot of them focused on the ethics of data collection and use, some key concepts for the activity, an instructional video of how to use the technology for each activity, and then usually a bit more advice, in this case, on how you might collect movement data, and more videos on key concepts for that are relevant to the activity. And at the bottom of each activity, there's a set of readings, academic articles, and also news, media, and video. So that gives you a really, quick high-level view of the website. What I did want to do is show you what this really looks like. So I'm just going to blow it up, and this will be kind of the final little bits I share here. hopefully I won't get an ad again. So this was a video that we created with Georgia Tech students. It was supported by kind of the Candida Building Challenge, I guess a couple years ago now, geez. So this is a group of students from a class at Georgia Tech, a computer ethics class. This is what it looks like when they're visualizing their own movement data that they've collected together. So paths are tracing their movement over a week. Dots are their particular movement at a point in time. You can see time elapsing. It's Tuesday, 5 p.m. here. It's going to get to the evening and momentarily, and I'm assuming, at 1, 2 a.m. folks are going to stop moving because they're sleeping. See if I can make this a little bigger, actually. There we go. Obviously, this should immediately, raise lots of questions for students about how data is collected. This is students, of course, from Georgia Tech visualizing their movement over a racial dot map of now Atlanta, not Nashville, where color on the map indicates race, as characterized by the 2010 census. As part of this activity, we actually worked with a local high school, and the high school students collected their movement as well. And we brought the students together and they compared and contrasted their movement. Quite powerful. This is what it looks like when you flip your movement into 3D in some of these visualization tools. And again, the purpose here, so time is now going up. That long straight line is actually a student sleeping. Right? And now they're moving again, they're coming back into campus. So it gives you a quick feel of what these visualization tools of physical movement data look like, can provide for your students. And of course, you can direct activities around them. For us and for this class, it was really focused on issues like data privacy, race and diversity on campus, and the general impact of computing technology on people's lives. These are some of the quotes from students. I think they're fairly general that I'll conclude with. Observing and looking at my own data felt both empowering and unsettling. This tension that was, very present for students, of course, through this mapping self and society framework. The realization that software companies are collecting all this data, and CS students have never really thought, like, how might technologies be designed differently or not designed based on this data? And a few more quotes just about more personally how it felt for CS students to collect their own data and see other people's data, with the larger point being that those feelings open opportunities for discussion that is really important and really relevant to what we talk about when we're trying to embed ethics, particularly around the collection and use of personal data. So I hope that roughly made sense. I'll go to the chat in a second. I hope I didn't speed through anything too much, but I did want to say two concluding thoughts. I think embedding ethics, I think Ellen, Jason, and Justin and I, over the last month in designing today, talked a lot about, embedding ethics in activities can be a highly engaging and rewarding experience for both students, but also teachers, for us. And it can facilitate deep discussion about topics ranging from ethical dilemmas students might face in their careers, specific to particular domain areas, machine learning and HCI, of course. And hopefully it also changes how students approach technical design projects. And I think Ellen and Jason will share resources later, but the work of Casey Fiesler and many other folks here, when you start bringing some of these activities into a technical course, it changes how the students approach design, which is a really important and powerful thing. So